Hi, welcome to Cloud Lab. My name is Marco Martinez, and today in our second part of our video series about computer vision, we will discuss about how to get data, in our case video data, from the drone into our computers, and also how to display that video feed in our internet browsers. Also, we will discuss about how everything works on a small, nice technical diagram on how the communications protocol work across the computer and drone. Please enjoy it and feel free to send me an email if you have any questions or use the comment sections. Have a nice day. Bye. So, hi once again. Thanks for watching. My name is Marco Martinez, and this is the second part of our video series about computer vision using DJI Tello drone. So for this second part, we will first take a look at how everything is tied together, so how everything is connected, and also how to fetch video information from the drone and display that video feed in a website, in a portal. So let's dig in. So let's start with the diagram. So here on the middle, I have my computer, and my computer is connected to public internet on the right using an Ethernet cable. That the Ethernet cable is connected to my router, and my computer is connected to the Tello drone using Wi-Fi. So when you normally turn on your drone, the drone will automatically start broadcasting its SSID. So you will be able to see the drone SSID and connect to that SSID. And once you are connected, let me give you one example. So let me turn on one drone. Okay, just give me 1 second. Okay, I have one drone on. And by the way, the Tello dash and the after dash, that's the ID, a unique ID for each Tello drone. So once your computer is connected to the Tello Wi-Fi, you can start sending UDP commands over port 8889. So we start from the top and go to the bottom and see what each port does exactly. So first, UDP port 8889, that's for sending commands. So if you take a look at the official SDK 1.3 or SDK 2.0, you have a list of available UDP commands. So for example, go up, down, left, right, take off, land, emergency land, turn clockwise, counterclockwise, or sending an RC command. And also, as you can see, that line is bi-directional. So over port 8889, you're sending commands, and once that command is completed by the drone or acknowledged by the drone, the drone will respond with an OK response. So it will respond OK, or it will respond with an error message, or an error in this case. And also when you're enable, so now let's go to the second port. When you enable command mode, the drone will automatically start sending its telemetry over port 8890. The drone telemetry, it's basically drone battery, temperature, flight time, and different sensors data that's available from the drone. I already made a video on last time explaining everything that's been transmitted by the drone on the telemetry string. It's a text string. And finally, when you enable stream on when you enable video streaming from the drone, the drone will start streaming video frames or parts of frames on port 1111.1. Something to keep in mind is that port 8890 for the telemetry, the drone is sending telemetry data at around every 100 milliseconds. And for video, the drone is sending video, it's 30 frames per second, so every 33 milliseconds. But one catch, the drone is not sending full frame, so it's not sending one whole picture, one full frame of video. No, it's sending parts of frames. So the UDP protocol is not large enough to hold one full video frame. So what the drone is doing is chopping one frame into 4 or 5 different sections and sending those over UDP. Those sections are sent much faster, but again, it's around everything. It's the video. It's around 30 frames per second. But just to keep in mind that the drone is not sending a full frame, but it's sending parts, and we will see that in a second. So let's start first with our code. So let me just go to the top first and see what is new, what is not new. So what is new? WebSocket. So again, we're receiving video data over UDP. So for that, we're using an UDP server on Node.js. So, but how we're sending that video, those frames, that video data to a web portal or to a website? And for that, we are using WebSockets. WebSockets are used for chats and are also used for video, for sending video. And the reason behind that is that WebSockets are much faster, much efficient, smaller also in size compared to an HTTP request. And also it's bidirectional. So it's not, for example, an HTTP request, you're requesting something and okay, the server has to respond back. That's not the case with a WebSocket. So the WebSocket can just send information over the same port, over the same, reuse the same connection. So it's much more efficient, much faster for sending, in this case, data over the network. So that's WebSocket. So something new. So we are now using or creating a new UDP server, an IP4 server, and this one is for receiving the video frames. In this case, are receiving a raw H.264 encoded on YUB 420p. That's the standard, the color format of each the video frames. We're also using Express server. Express is for hosting our HTTP server. That we'll take a look in detail in a second. So let's scroll down. This portion is only for the banner, so don't pay a lot of attention. Okay, again, Express server. So again, this is for hosting our portal or website. This is Express. WebSocket. We already mentioned that we're just sending information over WebSockets that are much faster for sending payloads. And here below on line 167, 166, 165, 164, that's our UDP server for receiving those video frames and buffering those video frames. That I'm gonna explain that in a second. So okay, so from now, so let me just take a moment to explain. So I already mentioned that the drone is sending parts or portions of frames over UDP. So again, it's not sending a full frame every X amount of time. So it's just sending portions of one full frame, of one picture of the video. So what we are doing here is basically first capturing one frame. So we're just putting all the pieces together and calling that a full frame. Then waiting to have 3 full frames and sending those full frames over WebSocket to our portal. So for that, okay, first, so we're again UDP, so we're receiving we were converting our UDP message to a byte array. That's a buffer. Then on line 173, what we're doing is that we're seeing if index of, so we were just searching for the position of this byte array 0001. If that's available, it means that this is the first part of a frame. So a series of parts that will form one full frame. So we're just waiting for that to basically say, okay, this is the first frame. Let's increase the counter and wait for 3 full frames and sending those 3 full frames over a WebSocket to our client. And this, in our case, is our web portal. And that's basically it. If that's not the case, we're just pushing that to another array that's just buffering or 3 frames. Again, this is to keep it small and also to keep it very efficient and small. So how we are decoding that raw video thing that we are talking about. So for that, if we go to our portal, so that's under public index. So the thing that's doing the magic for us, it's called JMuxer. So that's a library, and GS library. Let me just open it here. So these guys, what this library does is that they don't care about the format protocol of communication. They are just waiting for frames basically, and they will play it as an video MP4 in our internet browsers. So if we take a look at our portal or index file, we're first initializing our library JMuxer node. This is our container for our video. So in this case, this is our player. It's an HTML tag for video. So this is the player node. This is what kind of information we're sending to this JMuxer object. In this case, we're only sending video, and again, because the drone is only sending video data. Flush time, so every how many milliseconds we want to flush the buffer of this JMuxer object. So every 10 milliseconds. How many frames per second the video is supposed to be? 30 milliseconds. And debug is only for debugging, but we're not using that. Then we have our WebSocket. So our WebSocket, it's on, again, this is localhost 8080. That's pretty standard. We're just initializing that WebSocket. The binary type is an array buffer that we already discussed in when we're sending that information. It's a byte array. So buffer from it creates a byte array. And we're adding, it's creating an event listener. So every time the WebSocket receives a message, it's pushing that to the JMuxer object or video feed. And again, it's here. This is how it's pushing that to JMuxer video feed. So it's quite simple and quite efficient. How everything is tied together. So let's see it in action. Let me first try to open my drone. Let's turn on one drone. I actually have two drones. One has backup in case something fails, or in case I don't have enough battery, I have two. So let me first turn on one drone. Guys, give me 1 second. So connect. Let me connect one gamepad. I'm gonna connect my Xbox One controller. Okay, so we are connected. Yes. Let's start. I'm gonna hit RV on my Xbox One controller to enable command mode. Okay. The drone responded with an OK response. Now I hit it LV to enable video feed. And if we go to localhost port 3000, we will start seeing the video feed. So let me put the drone in the ground, and let's take off. So as you can see, it's working. Let me just move a little bit. So as you can see, it's working. And again, again, in case that you have, I'm gonna just use the drone as a video feed. Let me put here. So again, thanks for watching, and if you have comments, questions related to this project, just feel free to send me an email or post your comments on the comment sections of the video. Thanks for watching, have a wonderful day, and have fun, basically. Bye-bye.